Hello students, today we're going to continue this whole compound inequalities thing and I think we're on page 60 in our composition book, but I'm not sure. We're going to start out with solving or compound inequalities. We're going to solve and graph. So in a compound inequality, remember it's two parts. The first one is 9x plus 1 is less than negative 17, or 7x minus 12 is greater than 9. So the first thing we have to do is solve both of these, and then we're going to graph it on one number line. So with 9x plus 1 is less than or equal to negative 17, I have 9x is less than negative 18, because I bring the 1 over, and then divide both sides by 9, and I get x is less than negative 2. And no, I did not change my sign because I divided by a positive number on both sides. So we have or 7x minus 12 is greater than, 9. So we have 7x is greater than positive 21 because I bring the 12 over and it becomes positive. Divide both by 7 and I get x is greater than 21. X is less than negative 2 or x is greater than 21. So now I need to graph it, create my number line, find negative 2 on the number line, find 21 on the number line. X is less than negative 2, so open dot, arrow going this way. 21 is open dot, arrow going this way because it's greater than. So again, this really is nothing new. It's just combining a couple of things. Solving the inequality and then graphing both of them on the same number line. That's what we would do for OR statements. Now we're going to look at AND statements, and I love AND statements. They are fun. They're a little bit challenging, but I love doing them because they're kind of fun. So the first AND statement we have is 15 is less than negative 7x plus 1, which is less than 60. So you see there's a lot of stuff in here that we've got to figure out. And there are two different ways to solve them. And I'm going to solve the challenging way first, and then I'm going to solve the a little bit simpler way next, okay? So the first thing that I've got to do is, if I'm going to solve this whole puppy all by itself, then instead of having two sides, I actually now have three places where I have to do everything. Because you know in math, if you do it to one side, you have to do it to the other. Well, since there's now 3, then I have to do it to 3 different places. So I'm looking starting on the inside because my goal again is to isolate the variable. And right now we got a lot going on with the variable, so I'm going to do SADMAP. And that means I have to subtract 1 from everything first. So I have to subtract 1, and subtract 1. Once again, I've got to do it to all 3 places. So when I'm finished, I have 14 is less than negative 7x, which is less than 59. Now I have to divide everything by negative 7. And that means everything by negative 7. So I set it up like this, and I realized that I made a mistake. So instead of this being 60, that's actually supposed to be 50. And this becomes 49. And now I'm not confused anymore, because I was kind of confused. Why would I have that number? Anyway, sorry about that. That number's 50, this number's 49. So I'm dividing everything by negative 7. Well, you know when we divide by negative on both sides, or in this case on all 3 sides, then I have to flip the symbols. So I'm going to do that as well. So I have negative 2 is greater than x, which is greater than negative 7. I'm going to change that a little bit because it looks like a 7. And now, notice that I don't have the smallest number on the left and the largest number on the right. So I've got to flip this entire thing. So it's going to end up looking like negative 7 is less than x, which is less than negative 2. Now I have to graph it. The easy part. Draw my number line. Draw negative 7 on my number line. Draw negative 2 on my number line. And notice that I have 2 open dots. And it's the space between them. So x is greater than negative 7 and less than -2. So it's everything between -7 and -2. Just to recap, I solved it just like you know how to solve, trying to isolate the variable, but I just had to do it to 3 different sides instead of just 2. Now, if that last way just kind of blew your mind, confused you, and you don't like that, then I'm going to show you a different way to solve this. And the different way to solve it is to break it up into 2 separate inequalities. So the first inequality is going to be 15 is less than -7x plus 1. My second inequality, again, uses this whole variable statement. -7x plus 1 is less than 50. And there's an and in there. Okay? So I separate it into 2, and then I just solve the 2 individually. And so we know that I subtract 1 to bring the 1 over, and I get 14 is less than -7x. So x is less than -2. Because I had to flip the symbol when I divided by the negative on both sides. And then I have an and that says, and I'm going to solve this one, bring the 1 over, and I have -7x is less than 49. And then I have to divide by -7 on both sides, so I get x is greater than -7. Because I divided by -7 on both sides, I had to flip the sign. So now I have x is less than -2, and x is greater than or equal to -7. So how can I combine that into one nice, neat inequality? Well, I put the smallest number on the left, largest on the right. So I have -7 is less than x, which is less than -2. And notice when we have our inequality statement, the inequality symbols are always going to be facing the same way. They always turn out as less than signs. So now I can graph it, just like I graphed it before. -7 on my graph, -2 on my graph, open dot, and it's the space between. Because it's greater than -7 and less than -2, so that's everything that is in between those 2 dots. So here's one more example of an and compound inequality, and just because I know it can be a little bit confusing, we're going to solve it 2 ways. I'm going to do the leave it like it is way first. So the first thing I have to do is add 3 to everything, because again I'm trying to isolate my variable in the middle, so I've got to start with SADMEP, so I add 3 to everything. So I get 18 is less than or equal to 3x, which is less than 27. And now I have to divide by 3 everywhere. I don't have to change any signs or anything because there's no negatives involved. So 18 divided by 3 is 6, which is less than or equal to x, which is less than 9. So x is greater than or equal to 6 and less than 9, so it's everything between 6 and 9 on the number line. So I draw my number line, I draw 6, I draw 9. Now 6 is going to be a closed dot because it's or equal to. 9 is going to be an open dot, and it's all the numbers in the middle. So what does that actually mean? That means that I can have any number between 6 and 9 fits right here and makes this a true statement. So let's solve it the other way, and we'll break it up into 2 inequalities. The first one is 15 is less than or equal to 3x minus 3, and 3x minus 3 is less than 24. So let's start over here. I'm going to add 3 to both sides, so I get 18 is less than or equal to 3x, so x is greater than or equal to 6. And 3x is less than 27, and x is less than 9. So I would combine those into one inequality statement. See, my x's are the same, so I just put the x in the middle, greater than or equal to 6, less than 9, and graph it on my number line, 6, 9, closed dot, open dot, whoops, open dot, and all the space in the middle. So x can be any number between 6 and 9, including 6 but not including 9. And after this video, here are your 2 practice problems that I would like for you to solve and graph, and then take a picture of and turn in using the turn in button on Edmodo. The first one is 9x plus 1 is less than negative 17, or 7x minus 12 is greater than 9. And the second one, letter B, is negative 3 is less than or equal to negative 2x plus 1, which is less than 11. So again, solve these, take a picture, and then submit it as an assignment on Edmodo. I'm stalling a little bit so you have time to write these problems down because I know it's hard to go back and rewind. If you have questions, Edmodo me or send me an email.